ಇನ್ಯಾರಾದ್ರೂ ಜಾಯ್ನ್ ಆಗ್ಬೇಕಪ್ಪ? ಇನ್ಯಾರಾದ್ರೂ ಜಾಯ್ನ್ ಆಗ್ಬೇಕಪ್ಪ? Yes, Anubhav. Are there any more to join?
ಇನ್ಫಾರ್ಮ್ ಮಾಡಿದ್ರೆ ನಮ್ ಜಾಯ್ನ್ ಆಗ್ಲಿಕ್ಕೆ.
Yes, okay. So ನೆನ್ನೆ ಮಾಡಿರೋದು ಅರ್ಥ ಆಯ್ತಾ? ವೆಕ್ಟರ್ ಸ್ಪೇಸಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ. Now let us understand one more important concept with the vector spaces. Okay. So can you, any of you tell me another example of a vector space? Yes. ಇಲ್ಲಿ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ಅಲ್ವಾ? ಸೊ ಯಾವ್ದಾದ್ರು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳಿ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್. So yes, can someone tell me another example for the vector space? Vector space ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ? ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡಿದ್ದೀರಾ? ಪಾಲಿನಾಮಿಯಲ್ ನ ನೋಡಿದ್ದೀರಾ? So I got one response. So 0, yes, it can be a vector space. Yes, what about others? Any other answers? Yes, any other answers? Yes, guys. Just think over, as he said, 0 also forms a vector space. Yes. ಯೋಚನೆ ಮಾಡಿ ಹೇಳ್ರಪ್ಪ ಇನ್ಯಾವ ಎಕ್ಸಾಂಪಲ್ ಓಕೆ ಒಂದ್ ಕೆಲ್ಸ ಮಾಡಿ 2 ಡೈಮೆನ್ಷನಲ್ ಸ್ಪೇಸ್ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಆಗುತ್ತಾ ಯೋಚನೆ ಮಾಡಿ just check whether your 2 dimensional space forms a vector space where all your xi's belongs to the field of real numbers. Yes, all your xi's belongs to the real spaces, something like this. One second, I'm going to present my screen. Check whether 2 dimensional space is a vector space. Where it is represented as V is a set of vectors which is represented by the vector, say alpha is equal to x1 comma Yes. Is my screen visible now? Now is it visible? For X is in the field F. Visible. Yes, thank you. Don't worry about the link which is sent. Anyway, I'm presenting my screen, so you need not bother. Two-dimensional vector space which contains a set of vectors V, where each vector is represented as x1, comma x2, where I can say each vector alpha is represented as x1, comma x2, is a vector space. So you check whether it's a vector space where x1, x2 are in the field. Okay. To be more specific, I can say we are in the field of real numbers. I'm just reducing your job. Is that clear? So now can you tell me whether these forms a vector space or not? So just give a thought. So can you tell me whether this forms a vector space or not? Does yes, your two tuple space. Yeah, you can also call it as a two-dimensional space or a two tuple space. Both are same. Two tuple space. Two two tuple space. Yes. Do you have a zero vector? Yes, I want the response. Do you have a zero vector in this? Zero vector ಇದೆಯಾ ಇದರಲ್ಲಿ? Are you guys there? Yes. Are you people there? Anubhav? I'm not getting any response. Can you tell me whether there is a zero vector in this two tuple space? ಏನಾಯ್ತು ಶ್ರೇಷ್ಠ? ಸಾಂಗತ್ಯ? ಮನೋಜ್? Are you people there?
ಹಲೋ ಮ್ಯಾಮ್.
ಹೇಳಿ.
ಹೆಸರು ಕರೆದಿ.
ನಾನು ಕೇಳಿದ ಕ್ವೆಶನ್ಗೆ ಆನ್ಸರ್ ಮಾಡಿ ಅಂತ ಕರೆದಿದ್ದು.
ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಇತ್ತು.
ಈಗ ಝೀರೋ ವೆಕ್ಟರ್ ಇದೆಯಾ ಇಲ್ವೋ ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ? ಸಾರಿ, ಝೀರೋ ವೆಕ್ಟರ್ ಇಸ್ ದೇರ್ ಆರ್ ನಾಟ್? In this two tuple space of a vector space, do you have a zero vector? Your real numbers contains 0, so x1 and x2 can be 0. Is that clear? Since my x1 and x2 are real numbers, it can contain 0. Yes. Now check whether the sum of two vectors exists. So when you add two tuple space, what happens? Purvi? Rohit? ರೋಹನ್? ಯಾರು ಇಲ್ಲ ಅಂದ್ರೆ ಏನಕ್ಕೆ ಕ್ಲಾಸ್ ಮಾಡ್ಬೇಕು? You can better go out of the classroom.
Hello. Hello. Ma'am, your voice is breaking a little.
I asked
Hello.
you guys a question. You guys
Ma'am, ಅದು ಕ್ಲೀನ್ ಆಗಿ ಕೇಳಿಸ್ತಿರ್ಲಿಲ್ಲ ಮ್ಯಾಮ್. ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ತುಂಬಾ.
ಕ್ಲೀನ್ ಆಗಿ ಕೇಳಿಸ್ತಿರ್ಲಿಲ್ಲ. ಇಷ್ಟ ತನಕ ಏನ್ ಬಾಯಲ್ಲಿ ಏನ್ ಇಟ್ಕೊಂಡಿದ್ರಿ? ಅವಾಗಿಂದ ಕೇಳ್ತಿದ್ದೀನಿ. ಅದನ್ನ ನೀವೇನು ರೆಸ್ಪಾಂಡ್ ಮಾಡಲ್ಲ ಅಂದ್ರೆ ನಾನು ಇವತ್ತು ಕ್ಲಾಸ್ ತಗೊಳಲ್ಲ. ನಾನು ಕೇಳಿದ ಕ್ವೆಶನ್ಗೆ n ಟಪಲ್ ಸ್ಪೇಸ್ ಏನು, ಝೀರೋ ವೆಕ್ಟರ್ ಇದೆಯಾ, ಏನು ಹೇಳಲ್ಲ ಅಂದ್ರೆ ನಾನು ಏನು ಕ್ಲಾಸ್ ಮಾಡ್ಬೇಕು?
ಮ್ಯಾಮ್ ತುಂಬಾ ಬ್ರೇಕ್ ಆಗ್ತಿತ್ತು ಇನಿಷಿಯಲಿ, ಯಾರಿಗೂ ಕೇಳಿಸ್ತಿರ್ಲಿಲ್ಲ ಅನ್ಸುತ್ತೆ. ನಂದು ತುಂಬಾ ಬ್ರೇಕ್ ಆಗ್ತಿತ್ತು ಮ್ಯಾಮ್. ಕಾಲ್ ಕಟ್ ಆಗಿ ಮತ್ತೆ ಬಂದೆ ಮ್ಯಾಮ್, ಎಂಟರ್ ಆದೆ ಮ್ಯಾಮ್.
ಸರಿ ಆಯ್ತು. ಇವಾಗ ಹೇಳಿ, ಇಫ್ ಈಸ್ ಯೋರ್ ಟೂ ಟಪಲ್ vector space or not? I'm showing you presenting it in the screen also so that you can observe and tell me.
Presentation. Ma'am, what is the question?
Two tuple space is a vector space. Check whether two tuple space is a vector space where the vector is of the form where alpha is equal to x1 comma x2, and x1 and x2 are nothing but the scalars in the field of real numbers.
Okay, ma'am.
Zero vector idya adralli?
Every vector will have a zero vector, so it has a zero vector.
Yes, when x1 and x2 goes to 0, there exists a zero vector. So the zero vector exists. Now check whether when you add two vectors, the sum of those two vectors exists.
Yes, ma'am.
Yes. Say if I take a vector alpha to be x1, x2 and the y1, y2. So what is the sum of vectors alpha plus beta?
It will be sum of coefficients into the polynomial.
Yes. So here I'm talking about a vector space of n tuple space. The polynomial problem is done. It is the second problem. Okay. So now
Okay.
I have alpha plus beta. So what are the coefficients? X2 and y1, y2. So alpha plus beta vector will be x1 plus y1, comma x2 plus y2. So since x1 and x2 are real numbers and y1, y2 are also real numbers, when you add two real numbers, you get a real number. Is it not? So the sum of two vectors also exists. Check whether the scalar multiple of a vector exists. Check whether the scalar multiple of a vector exists. It exists. Yes. So what happens when I say it's a scalar exists? That is any number in the field I multiplied to a number in the field, that number exists. So scalar multiple also exists. What about inverse? So we all said the zero vector exists. What about the inverse vector? Is there a minus alpha vector for all vectors alpha? Yes. Minus alpha vector idiyappa? Minus alpha vector idya? When I say it's minus alpha vector, it is nothing but I'm multiplying the scalar minus 1 with x1 comma x2. Okay. So here I get only minus x1 comma minus x2. So are minus x1 and minus x2 real numbers? Or does minus x1 and minus x2 is there in the field? Yes. Good. So that means I can say the minus alpha also exists. Okay. So now with this, I can say that my two tuple space of vectors form a vector space. Similarly, now what about the n tuple space? What about the n tuple space? Will it form a vector space? Will it be a vector space? Same thing, I extend it to an n tuple space where my vector alpha would be yes. Now can you do the same operation as I did for a two tuple space and identify whether it forms a vector space or not? Where again all these x are in the field of real numbers. Do you have a zero vector here? Do you have a zero vector here? All the properties are same for n tuple space. Yes, good, Chetan. So now with statements what you have done, this two tuple space, I can extend it to n tuple space. I have a zero vector here. And then once I say I have a zero vector, what is the next thing I need to check? Whether when I add two vectors, I'll get back the vector which is present in the given n tuple space. Yes. When I add two vectors alpha plus beta, assuming it is y1 to yn, I get x1 plus y1 plus comma x2 plus y2, comma x3 plus y3 and so on up to xn plus yn is present in the n tuple space. Is it not? Similarly, the minus alpha vector also exists and the scalar c in c alpha vector also exists. So with this, I can say my n tuple space also forms a vector space. Now tell me whether a space of 3 cross 3 matrices which contains real numbers is a vector space or not. Tell me whether the 3 cross 3 matrices form a vector space or not. ಏನಾಗತ್ತೆ 3x3 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ನೀವೀಗ ಮತ್ತೆ ಒಂದ್ 3x3 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ತಾನೇ ಬರೋದು. When I add two 3x3 matrices, I get back a 3x3 matrix. And then do I have a zero matrix? That is, does a zero matrix exist in my 3x3 matrix? Yes. Yes, a null matrix exists. Do I have a minus A matrix? Assuming your matrix entries are again in the field. Okay, that I'm making it clear. So can you say a 3x3 matrix is a vector space over the given field F? So vector space ಅಂತ ಹೇಳ್ಬೋದಾ matrices ನ? Yes, they also form a vector space. Now, what about a set of vectors which contains all the matrices? A set of vectors which contains all the matrices. Do they form a vector space? All matrices. So it is not only a 3x3 matrix, I have all sort of matrices. Does they form a vector space? Yes. Okay, do one thing, give a thought and then come back. Okay. So now, having understood what a vector space is, now let us understand what is a subspace. When I say it's a subspace, say to make it simple, say I take a subset of my vector space V. Okay. I take a subset of my vector space V, and with that subset of vector space V, I will verify whether that subset itself forms a vector space. Are you getting it? Same as I discussed with the subfield, where I took a subset of the field and I checked with the properties of vector field. Similarly, I take a subset in the given vector space. I have not opened the presentation, Suresh. Okay. So that means I have a larger set of vectors, and from that I take a smaller set of vectors. And with this smallest set of vectors, I verify this itself will form a vector space or not. If the smaller set of vectors itself forms a vector space, then I call that as a subspace of the given vector space V. Did you understand it? So I have a larger set of vectors which forms a vector space. In that, I take a subset. So in that subset, I will check whether that subset forms a vector space or not. When that subset forms a vector space, now I can say the subset, whatever we have checked for the vector space, will form the subspace for the given vector space. The subset, which itself is a vector space, forms the subspace of the given vector space V. So you can see that over here. So that is what your subspaces are defined. A subspace of a vector space V is a subset H of the vector space V, which has the following three properties, where the zero vector of V is in the subset. So I should have a zero vector, and then I should also check whether H is closed under vector addition. That is, for each U and V in H, the sum of U plus V is in H. Is it clear? The zero vector of V is in H, and then H is closed under vector addition. That is, for each U and V in H, the sum U plus V is in the subspace. And the next point, I need to check whether it is also closed under scalar multiplication. That is, when I multiply the scalar C with the vector U, I get the new vector Cu, which is also present in the given subspace. Yes, that means every subspace is a vector space. Okay? And then properties are these three properties guarantees that a subspace of H, a subspace H of V itself is a vector space under the vector space operations which are already defined in V. Conversely, every vector space is a subspace by subspace of itself or possibly the larger spaces. Okay? So have you all understood what is a subspace? Before I get into the theorems, before getting into the theorems and examples of subspace, first subspace ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ ಆಯ್ತಾ? Yes, Geeta.
Yes, ma'am.
Visual. Akhilesh.
Yes, ma'am.
ಅರ್ಥ ಆಯ್ತಾ ಅಂದೆ?
ma'am, ಅರ್ಥ ಆಯ್ತು.
Subspaces. Okay. So having understood subspaces, can someone tell me an example of a subspace? Because you have also understood what is a vector space, and also you have understood what is a subspace. Just think over and tell me what are the examples of your vector space. ಯೋಚನೆ ಮಾಡಿ ಏನಿರ್ಬೋದು ಎಕ್ಸಾಂಪಲ್. ಈಗ ನಾನು ಒಂದು 8 ಆಪಲ್ ಸ್ಪೇಸ್ ತಗೊಂಡೆ ಅಲ್ವಾ, ಅದ್ರಲ್ಲಿ x1 to xn ಇದೆ. ಆ x1 to xn ಅಲ್ಲಿ ನಾನು ಅದು ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅಂತ ಹೇಳಿದೆ. ಸೊ ಇನ್ ದಟ್ ಐ ಮೇಕ್ x1 to be 0. Are you getting it? In that I make my x1 to be 0. And when I make my x1 to be 0, will it still form a vector space? When I make my x1 to be 0. That is now my vector space would be your n tuple space with x1 as 0. So are you getting it? My n tuple space with x1 as 0, then I would get all my vectors of the form 0, x2, x3, x4, and so on up to xn. So now I need to check whether this itself forms a vector space. Yes. So do I get a 0 vector when I make x1 is equal to 0 for all set of vectors? Irita 0 vector room. Yes. A 0 vector exists because this is already 0, and then I can have all these x2 to xn to be 0. So then I get a 0 vector. What happens when I add two vectors? Alpha plus beta, again I get 0 plus 0 is always 0. Then x2 plus y2, x3 plus y3, and so on up to x4 plus y4 is equal to, and again a vector in the given space. So can I say now an n tuple space with any x1 0 also forms a subspace? Yes, can I make that statement now? An n tuple space with x1 0 from subspace. Yes, a line through the origin. When you say it's a line through the origin, so will it satisfy all the properties? So assuming in your line you have 2 points, one is at 1, 2, and the other one is at 2, 3. When you add them up, will you get will it be present in the given line? Just check. As your friend made a statement that a line through a origin forms a subspace, check whether it forms a subspace or not. I assume this is the line. Can you tell me whether it forms a vector space or not? Say, take this to be 2, 2, and then again take another point 3, 5. Okay? And somewhere I would get it over here. It's just a rough representation. When you add those, you get 5, 7. Is your 5, 7 in the same line? Yes? Just verify and see. Yes. Check ಮಾಡಿದ್ರ ಮಹೇಶ್? ವಿಜುವಲ್ ಅದೇ ಲೈನ್ ಮೇಲೆ ಬರುತ್ತಾ ನಿಮ್ ಪಾಯಿಂಟ್? ಅದೇ ಲೈನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ಅಂದ್ರೆ you can say a plane can form a vector space. Yes. To some extent even I can say a single line can form a subspace, but again that is left to how your subspace is chosen. I cannot comment that your line cannot form a subspace at all. Is that clear? It can form a subspace. That's what you just need to verify it. Yes. Good. Are there any more examples you would like to share your which are the examples you have for your subspace so that I can understand how much you have understood what is a subspace? So any other examples? Can I say a point that is your origin form a subspace? As you all told me that zero forms a vector space. A set zero vector forms a vector space. Can you tell me whether the zero forms a subspace? Does your zero vector form a subspace or not? Yes, it forms a subspace of the given vector space. Say if I assume my vector space is an n-tuple space, so a zero vector will also form a subspace of the given vector space. And now, with this having understood what are vector spaces, subspaces, along with certain examples, as you all said, a plane can also form a vector space, a line can form a vector space, a point also can form a vector space. Now we will, with this unit, we'll be seeing certain theorems where this theorem makes your job easy in identifying whether they form a vector space or not. Okay, so we'll see with the theorem statements and its proof in tomorrow's class. Okay, any doubts till here? If you don't have any doubts, then you can go out from the classroom. Thank you.